Next, let's talk about queues. Queues are another important data structure similar to stacks. The difference is queues follow FIFO, which means first in, first out. They support two operations, typically enqueue and dequeue, but different from a stack. When we enqueue elements, it's the same as pushing. So in this case, it's actually similar to a stack. When we push elements to the end of the queue. That's called enqueuing. Now, dequeuing is removing a value, but instead of removing from the end, we're actually going to remove from the beginning. That's why it's first in, first out. The first element that we add is going to be the first element that we remove. Elements are going to be removed in the same order that they were added to the queue. And we want to do these operations efficiently. We want to be able to add to the end of the queue in constant time and remove from the beginning of the queue in constant time. We know we couldn't do that with arrays because if you remove from the beginning of the array, then you have to take every other element and then shift it over. That turned out to be a big O of n time operation. But with linked lists, we can achieve this. Let me show you how. So suppose initially we have an empty queue. So we'll have a current pointer, which is initially set to null. It has nothing. And then we add a value to our queue. Let's say we add red to our queue. Then we create a list node, and then our current pointer is going to be set to that list node because now we have one element in our queue. By the way, with this linked list, we will be maintaining a head and a tail pointer, which both are initially going to be at this node as of now. But we want to add another value to our queue. So we add another, in this case, blue to our queue. It's as simple as taking the next pointer of this node and setting it to the new node that we're inserting. At this point, our head pointer will be pointing at the first element here, and our tail pointer will be pointing at this, which is our tail. That's how we know when we insert a new element like this one, we're going to take the next pointer of the tail node and then set it to the new node. This is really easy with linked lists, but now it's time to do the other operation, which is dequeue, remove from the head of the list. Well, the good thing is it's as easy as taking our current pointer and setting it to be current.next. Since our current pointer is at this node, .next will follow the next pointer, which will be here. So it's as easy as that to take our current pointer and then point it to this node. And then if this is the beginning of our linked list, we can pretend like this doesn't even exist anymore. So dequeuing an element is very efficient. That's how we can do it in constant time, which you can't really do with arrays. But I do want to mention that technically it is possible to implement queues with arrays, but it can get a lot more complicated. It's much more simple to implement them with linked lists. Queues are a very commonly used data structure and we'll continue to use them throughout this course.